In this video, we're going to talk about classes. And in many ways, classes are a normal extension of the structs that we just talked about. Okay. So with a struct, we learned to group different data types together. Okay. So C++ also gives us what's called a class. And a class allows us to group both data and functions together. So classes are a very important topic in any language that allows them. Okay. So way back in chapter one, we talked about a problem-solving methodology called object-oriented design, or OOD. So in object-oriented design, the first step is to identify the components you're going to be dealing with. Okay, those are called objects. We'll talk more about how we create those as we go along. So these objects are going to combine data and then the operations on that data, okay, as a single unit. Okay. So a class then is a collection of a fixed number of components. So the components of the class are called the members of the class. Okay. So let's take a look at this example. We'll talk about just the general syntax here so we can ignore most of this for right now. So we start, sorry, my allergies are not good today. We start with this, the class name. Okay, so this class we have there's the class keyword, we have clock type, two basic sections here for now. There's a third we'll talk about later, and that's public and private. Okay, so inside of this, and we end with the curly brace semicolon, again, because these curly braces are not a block structure, so we have to put a semicolon on them. Okay, so we're going to list either the variables that we're holding. Okay, so in this case, those are all private. We do just like normal, int HR, int min, int second. Okay, and we usually start with those. When we think about an object, you want to think about what does it need to remember about itself. So this clock needs to remember its hour, its minute, and its second. Okay, we then are going to create functions to allow us to access and manipulate that data. Okay. So in this case, we have these are almost all void functions. We have a set time function, okay, which allows us to send in the 3 ints for the hours, the minutes, and the seconds, and it will set it for the object. We have a get time, okay, which is a void function, and it's passing by reference the int values there, okay. Note this constant keyword at the end. The constant keyword here means that this function, the get time function, cannot modify the member variables of any clock type that we call it on. Okay. Another constant function here in print type, just going to print out the time. Then we have functions to increment the seconds, increment the minutes, increment the hours. Then finally, we have a Boolean function here that it's going to take as a parameter another clock type variable. Okay. So we're going to be able to compare two clock types. We'll see that in a second. Now, there are two constants here, so it's important to realize what's going on. This constant here relates to the clock type we're sending in as a parameter, and we've seen this before. It means that the clock type we're sending as a parameter can't be modified, okay? The constant over here at the end is protecting the calling object, okay? And it can't be changed either, okay? So those are kind of the basics to get us going here. So a few more things to think about here. We've talked about most of this. And again, with those member access specifiers, there are three. We use two at this point. Okay. The private is by default. And it means that we cannot access that function or that member data variable from outside of the class directly. Okay. Structs are all public, which means if we have a struct called X and there's a name, we can say X.name. Okay. Well, if it's private, which is a default, you can't do that. Okay. You have to access it from functions that are within the class. Okay. If it's public, then you can access it outside the class. Okay. Protected, we'll talk about in a later chapter. Okay. So what this means practically here is that in this, if we create an instance of clock type, just like we did with creating an instance of a struct, it's going to have an HR, a minute, and a sec, okay, for hours, minutes, and seconds. But in our code, we can't just address those, okay? So if we were to say, for example, down here in my int main, this is how we declare a clock type my clock thing there. It's not a function, okay? Once we've done that, okay, what I can't do is see out directly my clock dot HR, for example. Okay. That's going to give me an error because HR is private. Okay. So the book briefly talks about how these get stored in memory. So when you create a new instance, and that, so my clock now is an instance of clock type. Okay. So clock type is a class. My clock is an object of type clock type. Okay. So it's kind of, we use the terms, it's a cookie and a cookie cutter. So clock type is the cookie cutter. My clock in this case is a cookie created by that cookie cutter. Okay. So since the data is private, okay, the only way to get to it is through a function. Okay. So this is why we have the set time, because I can't just say, my clock.hr is equal to 5. I have to set the time through this function. Okay. Same thing with the get time. Okay. I can't just print it out. I have to be able to get it this way. And this is going to return variables, the 3 variables that you send it. Okay. Also to print it out, I can't get to it that way. The same way, if I just want to increment either the seconds, the minutes, or the hours, I have to have functions for that. Okay. Now, functions within the class can access all of the member data, whether it's private or not. So inside of these functions. Okay. And then, and that's the basic idea there. Okay. So let's talk about how we're going to actually do this. And I'm now into example 10.1. Okay. In the book. So I have a clock type, my clock. I have another clock type called your clock. Okay. I can do the following. I can do my clock dot set time to hours, minutes, seconds. Okay. So that function, we haven't defined that function yet, of course, but once we define it, that's what it'll do. Okay. And then I can have my clock dot print time. Okay. Which will print out those values in whatever way we specify when we do that function. Okay. We can do a your clock dot set time. Let's say we've got X, Y, and Z. This assumes that these variables are of type int and have already been set up. You can do that. Okay. We're just doing some kind of, this is not a real program, it's a program part snippet. Okay. So we can do something like if my clock. So we want to do that equal time. Okay. Dot equal time. We're going to send your clock as the parameter there. Okay. And then you can whatever you're going to do. Okay. So that's the basic idea. So again, we can't just say that my clock.hr is equal to 5, or we can't print out that. Okay. So so that's an important thing that we can do here. Okay. So as far as built-in operations, most of the things that we do with C++, like addition, multiplication, all those things, you can't really do with classes. Okay. So we have the ability to, so I can't say clock, my clock is equal to your clock plus somebody else's clock. That doesn't work. Okay. Now you can define those functions and overload them if you want. We'll talk about that in chapter 13. Okay. But the things that we can do an assignment operator, the equals. Okay. And then we can use the period, which we're using here, like to access public data. Okay. So again, the assignment operator, if you would say something like my clock is equal to your clock. So if we're going to do that instead, but we don't want to set this one. Okay. So your clock is a valid type. So I can say, or I could type clock is equal to my clock, which has a value. Okay. So this creates its own object. And now um, it has the values 5, 2, and 30. Okay. So those get copied over. Okay. So um, we can create our classes normally, and they have scope wherever like normal scoping rules would follow. Okay. We can also do a static if we ever needed to. We've talked about static before, where static, once it's created, allows you to kind of break the rules of scope. Okay. There's only one instance of it floating around. Okay. As far as classes and functions, okay, class object can be passed as parameters, no problem. Okay. They can be returned as function values. If you're passing parameters to functions, it could either be by value or by reference, just like always. Okay. If a class object is passed by value, because you can also pass the class objects themselves, either by values or by reference. Okay. If it's passed by value, then you're creating a temporary new class, and all of the values are copied to that. Okay. So as you would expect. Okay. So again, if you pass by reference, then um, the function only gets the reference, the memory address, basically. Okay. So it can then make changes that are actual changes. Okay. Unless you would do a constant keyword. Okay. So as far as implementing these member functions, okay, we have to write a definition for them. Okay. So let's take a look at what that would look like. And we have a couple of options here. Okay. We can either define them inside the class. So basically up here. Okay. Which can be okay, but can get kind of cumbersome. So what tends to happen, they tend to be defined outside of the class, but before int main. Okay. So in this case, I'm going to work up on the clock, the set time. So we have to prepend here this namespace identifier. Okay. The clock type : : Okay. This lets the compiler know that this function we're defining is not a general function. Okay, we can't call it from int main just by itself, but that it has to be called to the right of a period where the left is a valid function of that type. Okay, so this is for clock types only. We'll see how that gets. Well, we're seeing it up here down here. So we have to call it this way. I can't just do that. Okay, that's not valid. Okay, so it has to have a valid member of the clock type that we're calling it from. Okay. And then again, we're copying the parameters from above. So we have int hours, int minutes, seconds. Okay. And we're then just going to define what we do with each of those. Okay. And you may be asking yourself at this point, why do we make the data private and have to go through all of this? Okay. The reason is by making it private, we have control over how things get changed. Okay. So we can limit what the hours are to make sure they're valid values. We can make sure that it's all correct. Okay. So we control how things are changed. You can't write your own, if you're a programmer using this class, you can't write your own functions to manipulate the private data. Okay. So in this case, we're going to have an if 0 less than or equal to hours, and hours is less than 24. Okay. I don't love the number on the left here. So I would say actually hours greater than or equal to 0, but this does work. Okay. So we're basically making sure here that our hours are within the proper range. So we're assuming a 24-hour clock, or a military time, as we sometimes call it. Okay. So if that's true, then HR is equal to hours. Okay. So the HR here refers to this HR. Okay. Where the hours here refers to the hours we're passing in as a reference or as a parameter. Okay. We're going to put an else here. So if they try to do something that's illegal, okay, that's not in that range, we're going to set HR equal to 0. And you certainly could do other things. You could go through and give an error message or let them keep trying or whatever. Okay. But we're just going to set it equal to 0. We're going to do something similar for the minutes and seconds. In fact, I think it's worth cutting and pasting. Maybe not. Okay, so if 0 is less than or equal to the minutes, that's a parameter we pass in. Minutes is less than 60. Then we're going to set min is equal to minutes. Okay. Else we're going to set min to 0. And same thing here on seconds. If 0 is less than or equal to seconds, and seconds is less than 60, then we're going to set SEC equal to seconds. Else we're going to set SEC equal to 0. We then close that function. Okay. So that's all we're doing here. Okay. So this is a void function. We have to use 3 parameters, and it changes the internal state of the class. Okay. And it can do that because it's defined as part of the class type. Okay. We can access it from a regular program from int main because it's in the public section. Okay. So that's how that works. Okay. Other things that we can do, we'll go through some other examples. We don't have to do them all. You can read about them in the book, but we'll go ahead and look at the print time function. Okay. Again, so it's going to be void clock type : print time. So a constant function. We're going to say if HR is less than 10. And we're doing this so we can prepend a 0 if necessary. We're going to see out a 0. Okay. Then we're going to see out HR and a colon. Okay. In a similar way, we're going to say if the min is less than 10, so if it's only 1 digit, we're going to see out this 0 as a placeholder. I'm going to see out the minutes and a colon. Okay. And we'll do the same thing for seconds. So copy this. Doesn't matter. The sec is less than 10. See out the 0. Then we're going to do the sec. We're not going to do. We'll do an inline at that point. Okay. Close that one out. Okay. And then our increment functions just add 1 to those. So nothing really new there. Okay. So those are all in the book. Okay. I do want to go ahead and do the equal time function. Okay, that's a little bit different. Okay. So again, this is a bool function. It's a clock type, equal time. Takes constant, clock type, ampersand, because we're passing it by reference. Other, call it whatever you want. Other clock is okay. Anything works there. Okay. And this is a constant as well. Okay. So in this one, we're going to do a return of the following. Okay. We're going to do HR equals other clock dot HR. Again, we can get to that because we're an internal function. Okay. Whatever the value of that is, true or false. Okay. And min is equal to other clock min, and second is equal to other clock dot second. Okay. So if all of those are true, it will return true. Otherwise, it returns false if any of them are different. Okay. So again, the other clock refers to the clock that we're passing in. Again, this constant protects the other clock that's coming in. This constant protects the clock that we're calling it from. Okay. So that's the basic way that's going to work. Okay. So the last thing I want to talk about in this video, it's probably already a fairly long video, sadly, is the idea of accessor and mutator functions. Okay, that's sometimes referred to as getters and setters. Okay. And the idea here is that since we can't directly get to private member data, okay, just to print it out or whatever, we have to use an accessor function to get to it. Okay. So we don't really have them in this function per se, but let's go back up to here. An accessor function, and sometimes in a program definition or in a problem I'm giving you, I'll say, create this function with all accessors and mutators. Okay. So an accessor, we'll look at these, are all going to be of the form. Okay. They return the type. So we have an int get HR. Okay. Doesn't take any parameter at all. Okay. We have an int get min. We have an int get seconds. Okay. And all those do is just return the value. Okay. Then we have the mutator function, which are the setters, and that allows you to modify values. Okay. So we've got kind of group here. We've got the set time is an accessor for all three, and the get time is an accessor, or is a mutator for all three of those. Sorry, the set time is the mutator, the get time is the accessor. Okay. And we usually are going to put the constant keyword in our accessor functions. Okay, just to make sure that that they don't get modified. Okay. So in our example here, again, we've got the get time here has that. Okay, so all of these will have the constant keyword. Okay. Okay. And then that just allows us to get to that data. Okay. And then again, for the mutators, those would be void functions typically. Okay. And would be set HR. Okay. And that would take an int. Okay, then it would be the same thing for set minutes and set seconds. Okay, it's important that in this case we're doing the group mutator, but it's important that you make sure that your values are of the proper range. Okay, which is why we do that. Okay, so that's the basics of classes. Okay, we've got 2 more videos coming about this, but that in general is how we're going to set up our classes. So again, they're like structs in many ways, but they add functions. So there's more that they can do, and they have this whole idea of public versus private, okay, which is different for us. Okay. So also in this section, it talks about UML models. Okay, and UML models are pretty important. It's something that we certainly need to know. Okay. So I think for the UML models, I'm going to make that a separate video because we're going to be using a drawing tool of some sort. So look for a separate video on that. Not guarantee. So UML stands for Unified Modeling Language. Okay. Not guaranteeing that that will go out today. That may go out later. We'll get to that more as we talk about it. Okay. Anyway, that should get us going on classes. So if you have any questions, make sure that you let me know.